All right, everybody, welcome back. We're going to talk today about combating the hostile forces of nature. So, over the course of our evolutionary history, we've talked a lot about how survival and reproduction are critical for human evolution. And surviving the elements and being able to live long enough to reproduce and pass your genetic traits on to your subsequent generations is an important part of that process. So, one of the main challenges to survival in the environment is getting enough food, right? Gaining calories while avoiding poison, right? Toxins. There's a lot of stuff out there. I mean, think back, imagine 10,000 years ago, right? Prior to any kind of real industrialized societies, getting the enough nutrients from the environment while avoiding things that would kill you or make you sick was much more of a challenge than it is today. And so we've talked about this before. We're going to delve into it a little bit more deeply now. Imagine someone who doesn't like pizza, right? And there are people that don't like pizza, right? And there's variability in our liking or not liking of different foods. But it turns out that over history, those that had a preference for foods with high caloric content would have been more likely to pass that on, right? Because if gaining enough calories is a struggle, then those that like high calorie foods would have an advantage. There are all kinds of evidence or cases in which we can look at food acquisition across the animal kingdom and how different species have evolved. So, for example, rats also have taste preference for sweet foods, but when they come across a new food, they only try it in very, very small doses, right? Because rats can't throw up. And species that can throw up have a way of getting rid of something that you've eaten that might kill you or make you sick. So what rats do is they take a little tiny taste of something that they would first, a novel food for them, and then they go and they wait. And if it doesn't make them sick, then they'll go back and have more. But this is clearly a process of evolution, right? And it's a behavior that has evolved. Humans also avoid toxins, right? And it's not just the actual toxins that they avoid, right? So there are some experiments that you'll see here. So what they do is they take brownie mix, only they shape it like cat poop. And they put it in these little tubs that look like litter boxes with oatmeal. And a blindfolded listener or blindfolded viewer comes and takes a sniff and, oh, that's really good. It's like chocolate, oatmeal. And then, of course, when the blindfold is removed, they're disgusted. Why is that? You can tell that it's chocolate brownies, right? But we've evolved this kind of disgust response to anything resembling something that might make you sick. And there are tons and tons of studies on disgust. So Paul Rosen is a guy at the University of Pennsylvania who's done stuff like had a glass that had some like nasty stuff in it, and then it was cleaned in a centrifuge and completely disinfected. But people wouldn't drink out of the clean glass, and there are all kinds of stuff like this, right? So some of you probably have a thing about bathroom water, right? So you can drink water out of the kitchen sink, but there are some people who won't drink water out of the bathroom sink. Same kind of principles apply here. So when we look at how people use spices across the globe, the antimicrobial hypothesis says that because food is more likely to go bad in warmer climates, then people in warmer climates would be more likely to use spices. And in fact, if you look at the evidence, that's exactly what we find. So the adaptive problem here is to keep food around long enough to before it goes bad, so to be able to eat it before it goes bad. And the preference for spices or lack thereof is something that will vary by culture. So here we're talking about something that's variable by culture, but also supports the evolutionary hypothesis that people have preferences for spices based on the ability to keep the bacteria from attacking the food, and based on their kind of geographic location and the weather that goes there. So spices like garlic and pepper and all these other kinds of things are antimicrobials. And so the hypothesis here is that the use of spices should vary based on how likely it is based on climate for your food to go bad. And there's pretty good evidence of that. We've read about pregnancy sickness and how it is a behavioral adaptation. We find really good evidence for this, right? So sicknesses in the first trimester, when the developing fetus is most vulnerable to teratogens from the environment ingested by the mother. And it turns out that the foods that are most aversive are ones that are most harmful to a developing fetus. And from medical evidence, we know that women who do not have any morning sickness are 3 times more likely to miscarry. So there's good converging evidence that pregnancy sickness is an adaptive behavior that has evolved over time. So what about getting food? So we've talked a little bit about avoiding poisons. So we have hunting hypothesis, we have the provisioning hypothesis, we have investment in children, and we know that meat is one of those high-calorie things that's easy to transport, right? So let's look first at hunting. We know that there is traditionally a division of labor among our ancestors. Male coalitions require cooperation for successful hunting, right? So you can't, by yourself, typically take down a large animal by that. So it requires cooperation. Unfortunately, so does war. So there's some good evidence, or at least some hypotheses, that suggest that the formation of male coalitions for purposes of obtaining food and hunting are also things that have led to the evolution of war. So social exchange is also thought to be kind of related to hunting, right? So hunting can be hit or miss, right? Sometimes you go out and you don't get anything, and other times you get a big buffalo. But it's hard to eat a buffalo by yourself before it goes bad. And so the coalitions would be, we would share food among the coalitions, right? The idea that you gain social status by sharing food is one that has not gone unnoticed by evolutionary psychologists. We look at sexual division of labor with respect to hunters and gatherers. We know that men were typically the hunters, and we know that the evolved characteristics of hunters would favor things like size and speed and throwing ability. And we also know that if we look at differences between men and women, almost all the differences between men and women that we find that are reliable are very small differences. Some of the largest differences between men and women are those of size and speed and throwing ability. Archaeologists know of stone tools that were used for hunting and for cutting meat. There are some hypotheses that suggest that these tools may have also been used for gathering with respect to digging for roots and other types of things. Hunting is also related to the show-off hypothesis. So if you're a good hunter, it increases your social status. We know that most of the meat from a successful hunt by the person who killed the animal is given away because it goes bad before it can be used. But you gain other resources from giving that, right? So you get social status, you get favors. And so the show-off hypothesis is essentially the idea that you can gain social status in a community by being a successful hunter. So modern hunter-gatherer societies show evidence for this. So if we travel to Papua New Guinea and look at modern-day hunter-gatherer societies, the good hunters tend to obtain higher social status. What about gathering? So some folks have suggested that gathering was also a primary force in evolution, and it was certainly a force. But if it was enough, then the idea would be, why wouldn't men just gather, right? If you don't have to go out and risk your life with respect to facing a wild animal, it might be better just to stay home and gather. But first of all, we have evidence that they didn't do that, right? And secondly, the high caloric content of meat is something that plays into this thinking in a large way. We needed those large calorie kind of foodstuffs to feed this kind of growing brain. Hunting explains the division of labor. It it explains male coalitions, and the tools that were made for hunting certainly could have also been used for gathering and digging, but it's likely that it's not their primary intention. All right, we've talked a little bit about sex differences in here, and I want to talk a little bit about why it's controversial, right? So when we have folks that are talking about sex differences, they tend to say, look, men are better at this and women are better at this. And what they ignore is the overlap in the populations. So what I have here are two distributions. And the trait that we're talking about can be anything, right? It can be throwing ability, it can be verbal fluency, it can be spatial memory. We know that there are differences among men and women on all of these kinds of traits. We also know that the differences are pretty small. So if you look on the bottom panel here, we find that the difference in averages between the two groups is really small. It's a reliable difference, but it's a small difference. But people tend to just talk about these differences and say, oh, well, men are better at this and women are better at this. What it ignores is the amount of overlap that is in these two distributions, right? So let's say that the blue or purple or whatever line is, my color vision is not so great, is our male responses, and the green line here are the female responses, right? We can focus on this difference, but down here between the male and female averages. But if you just focus on the difference between male and female averages, you ignore the wide variability inside each distribution, right? So this difference between the two distributions, the average difference between the two distributions, is much smaller than differences among individuals within the distribution, right? So there's a bigger difference in whatever trait we're talking about here among women and among men inside the two groups. There's a bigger difference than there is between the two groups, right? The average difference between the two groups down here is pretty small. The difference among each group inside each distribution is a lot bigger. So what do we do from this, right? So we can use sex differences in any of these traits as evidence for an evolutionary input into the outcoming behavior. But we can't use sex differences to make any predictions about any individual abilities of a man or a woman, right? So we know that, for example, there are sex differences in spatial ability. We know that men have better spatial transformation ability. We know that women have better spatial memory. Does that mean that because you're a man, you're not going to be good at spatial memory as a woman? No, there's no way to tell, right? We know that if you average all the people together, there are differences between these two, but you could be anywhere along this continuum from here to here and be a man or a woman. So there's a lot of overlap among the distributions. It's controversial, and some people don't like to talk about sex differences because some people use them with just the bottom panel here. So, oh, men are better at this, women are better at that. Women shouldn't be allowed to do this. And that's just ridiculous. It overlooks the overlap in the distributions. There are some places that don't find sex differences. So, for example, Stanford University has folks that have done work on sex differences, and they don't find sex differences in, for example, mathematical ability. Why not? Well, because they got really, really smart people that go to Stanford and major in mathematics, right? And if you look way up here on the very top end of the distribution, there's really no differences between males and females when we get way out here in the tails of the distribution. So if you're at Stanford and you find evidence that there's no difference among men and women in mathematical ability or spatial ability or verbal fluency, for that matter, where women have an advantage, what we find out is that, well, yeah, if you test the distributions way up in the tail, then there's no difference, significant difference between them, because you're testing people who are at the tail of the distribution, and they're not very representative of the population at large. All right. So this is just another example of some evidence that shows that men are better at spatial manipulation on average. That doesn't mean that that every man is better than every woman. Far from it. But these skills are related to hunting, right? So being able to tell where something is going to be 2 seconds from now, right? When you have to kind of throw a spear at it or whatever. These skills are related to hunting, and we do there's mental rotation tests where you have to imagine what something would look like in a different orientation. So the task is, are these two figures the same, you just rotated in space, or are they different objects altogether? It's like the Tetris game, right? We find that women have better memory for spatial location, which is related to gathering, right? So simple paper and pencil tasks like this, where you see a display of a bunch of objects, and then you see the display again where maybe one of them is missing or they're moved around in space, and women are much better at noticing either what's missing or where something was moved to. Anecdotally, when I lose my keys and I ask my wife, do you know where my keys are? She says, yep, they're downstairs next to the coffee maker. And I'm like, oh, how'd you know that? She just knows. All right, so now we're talking about selecting an environment in which to live. Humans have evolved preferences for landscapes that are rich in resources. It sounds crazy, I know, but where there is food and water, people prefer to live. Places where one can be seen or can see without being seen, kind of mimicking the savanna, where we've kind of pinpointed the kind of really kind of the birthplace of the human species, right? Simple evidence that supports this is this kind of study on cross-cultural tree preference, right? You show people different types of trees, and you just say, which one do you like better? Very kind of open-ended experiment, right? And they overwhelmingly pick the one that you could most likely climb up into and be safe from other things that are kind of prowling around on the ground, right? And it occurs across cultures, right? So does that show that we have an evolved preference for this kind of tree stuff? Does it prove? No, but it's one piece of supporting evidence. Remember what we're trying to do here. We are creating a case with circumstantial evidence, but we want to make an overwhelming case. So if we can find cross-cultural evidence, that's one piece of the puzzle that suggests that there is this preference for these types of environments. All right, so now we get to the kind of hostile forces of nature, right? All habitats have dangerous things in them. Humans have evolved specific fears to avoid these, right? So people don't like spiders and snakes. And it turns out that, or heights, or strangers, and these are cross-culturally universal. They also emerge at specific times during development. So if you've taken a class in developmental psychology, you'll know that fear of strangers develops right around the time that kids are able to start moving around on their own. There's probably a really good evolutionary reason for that. There's an adaptive patterning of these specific fears. Organisms that had these fears avoided spiders and snakes and dangerous things, and didn't wander off from their family, and passed those preferences on to their offspring. Humans have many responses to a fear-inducing stimulus, right? Freezing, running away, fighting, submitting, playing dead, or even fainting are all evolved responses to threats and fear. The fact that we have these fears to things that we have evolved with, and we don't have them to things that are more recent in our history, suggests that there is really this adaptive characteristic to these fears, right? So we know that people have phobias of spiders and snakes, unreasonable, debilitating fear of spiders and snakes. But they don't have these to cars and electricity. But we know that cars and electricity in our modern society are way more dangerous than spiders and snakes. Why would we not develop these fears? If it's all this kind of cultural learning thing, we should have greater fear of cars and electricity than we do spiders and snakes. But we don't. We have this legacy heritage of fearing snakes because it's an adaptive evolutionary process. We have physiological responses. So for example, fever in response to infection makes the body less hospitable to the bacteria or virus that are infecting the body. There is this kind of phenomenon that if you have low iron, It turns out that that's maybe in some cases not so bad for you because iron feeds bacteria. Sometimes elderly people take supplements for iron because they have low iron, and that might not be the best thing for their actual health. So that's just a quick overview of the hostile forces of nature. We'll have some more for you coming up soon. Let me know if you have any questions. Take care.